Hello, everybody. I think we'll make a start. Good morning, good afternoon, good evening to you all, wherever you are. First of all, I'm going to start with an apology regarding the time zones. Anyone who was hoping to attend earlier, thank you so much for returning to the webinar. We've learnt a lot about time zones this morning. So our standard understanding of time zones is quite different to Zoom, which is probably technically correct, but thank you for attending. Just checking in, we just make sure all the panelists are available, which is ourselves and Duncan from AVA, and the demo will be done by Rachel Douglas, who some of you will have met. The second partner in this webinar today is Cruse, who I'm going to hand over to shortly. Cruse is represented by Jens Becker and Martin Paffrath today, and they're going to be showing how their scanners, their wide format scanners, can produce wonderful 2D and 3D scans. And then the scan data is going to be passed over to Rachel using AVA, who is going to show how our software, we've come up with a very nice and unique feature which allows us to edit the 2D and 3D data live in our software to prepare a design for production and prototyping. And once our section of the demo is complete, we'll be handing over to Stefan Hufs from Roland, who'll be showing how the Roland technology can produce digital prototypes of the design that you've edited, either the original scan or an edited version. Now, in today's demo, we're going to be using a nice decor design, but of course, if anyone's logging in from a non-furniture stroke flooring sector, this technology is very relevant to people designing wall coverings, ceramics, potentially textiles if you want to produce the feel of a particular weave, and obviously 2D scanning as well. If you have any questions, please put them on the chat and we will try and answer relevant questions for each partner at the end of each section, but certainly at the end. If we run out of time, we'll just we'll try and contact you afterwards. Okay, so Jens, are you there?
Yes, I'm there. Do you hear me?
Okay, Jens, I'm handing over to you.
Okay, great, thanks. Well, first of all, thank you for all the attendees of this webinar. Yeah, it's a fantastic new possibility to show you all our possibilities. And thanks for all the partners, contacts, and Cruse users for joining here. And for those who don't know Cruse yet, I'm going to give you a short introduction regarding Cruse. So we're going to share a file with you, and that should be working. Okay, I hope. Does everybody see the Cruse file? Okay, so we're fine. We can go on from there. Well, just to talk a little bit about Cruse, for those who don't know Cruse yet, I mean, we have over 100, I assume, over 100 people joining the webinar. Cruse, a medium-sized company from Bachberg, Germany. We are since 1979. We manufacture customized scanners, all sizes. Okay. We are worldwide spread with more than 800 scanners already out. We have showrooms in Houston, in China, and of course here at the headquarters at Bachberg. Our main industries are the archives, the fine art reproduction, and the decor industry, the service providers, and of course the museums and the libraries. I'm not going to go over all the scanners you see there because we just lack time. But what you should consider is there's actually nothing we can't build if it's technically and physically possible to be produced. Okay. We have at Cruse, we call each other a manufacturer. So we have a software team here, we have a construction team here. We do the melting, we do the coating, we know all the cameras in the market. So whatever you need, we can build it. And therefore we have very strict, what you see on the first page, customer sizes and options. So we have a portal scanner, I don't know, 1.80 m by 2.50 m, whatever you need. We have a 3D photo station for objects. We have museum scanners which can scan walls. We have then special archive scanners, backlight scanners, book scanners. So we have a wide range, but most important for us is what are the needs of the customers, and then we sit down and try to find the perfect solution for you. I'm just addressing 3 scanners. The Synchron table, which is our main scanner, since it's 700, 800 of those have been already chipped, which is very unique in the world, the variable reproduction angle, because usually you never see straight down on a laminate or on a flooring, you always see on an angle. So we're the only ones in the world who can scan with an angle, and we have variable resolution up to 2400 dpi. We build many sizes, and then the surface scanning, this is then what Martin will be talking about. What is new? We can also build portal scanners, 3.60 m x 2.50 m. It depends on the resolution. It can be with 1200 ppi or 600 ppi. It has a telecentric lens. It has a fantastic 10 × 10 micron pixel size, which gives you a lot of contrast and which is really giving you a very, very high quality. We have specialized and built LEDs for that. So this is a new scanner. Whenever you're interested in this kind of scanner, give us a call. What Martin will talk about is also something new, which we came into the market last year. This is what we call the table scanners. The table scanner has a size of 60 × 60 or 60 × 1.20 m. It has either a resolution of 600 ppi or 300 ppi. It has our famous 15K CMOS linear sensor, which has, and that is also unique, 5.6 micron pixel, which allow fantastic results. We have also a 7K sensor with 10 micron pixels, and what is also available is that the original height is 10 centimeters, and it can carry 30 kilometers max, which at that side is also fantastic. It has a magnetic board, and you can do 3D surface scanning with it, okay? Price-wise, that is, of course, the most economic scanner. And those who know Cruse, this is below 100,000 euro, depending a little bit on the options. So if you're considering to get a high-end Cruse scanner at an economical price, and of course with less functions, but all the possibilities to scan 2D or 3D, take a look at this table series. So I think I'm going to pass over now to Martin, who will go on and show you what you can do with this table scanner. Thank you for joining, and have fun with the sample and the explanations from Martin.
Okay, hello. So I need 1 second to prepare. So. So hopefully you see now the scanner on the right side a little bit and the software on the left. Yeah, this is our new Design Studio software, which is which have all our different software tools inside. So it starts with this home view where you can see all the previously done projects. We have here Project Explorer. I will go fast through it. This is our scan software. This is image stacking, which is able to mix 2D scans together. Factory here is important because it's calculating the 3D depth information, what we will do today. We can do printer profiling with our software. Yeah, that's our main features. So what I will now do is I will start a scan for 3D scanning. So I press on this, and then the workflow process starts. I need to do it like this. Okay, 1 second. Warum ist das denn jetzt hier für eine Scheiße? So then we need to put here. So I hope you can see it. Can you? So this is now the workflow process, and what I will do is I will, I have to select the name. Like wood, for example, the sample we are scanning is wood. And then I can select here on the right side that I want to do a surface scan, a 3D surface scan, which is I need to select here. And then the software already is doing all the settings I need to do to be able to scan, including the 3D data of the surface. So let me start it. Now I need to try to get the camera again. This. Okay, so then what I will do is I will do a pre-scan. So this is the 60 by 60 centimeter version. So then I will start a pre-scan to be able to select the scan frame. And of course, the original height here have to be set up at the upper left corner, which is 7 centimeter here. And now I do a pre-scan. So, okay. So you can see already scan speed is very fast. So this is a light angle device mode, because what we need to do is we need to scan for 3D surface scanning. We need to scan in 4 different light directions, and this is what I will do now. For this we are using our light angle devices, which is in this scanner just, you can see it here, some lens plates which slide into the lamp. So the pre-scan is already done. So I need to select the area I want to scan, and then simply start a group scan, and the modes I need to do are already selected here, as you can see. So I will start the scan, and now the software will guide me through the whole process. So it will now do the first, I need to do 4 scans. After 2 scans are finished, I need to switch the lens plates to do the 2 other light directions. So this is what the software will do now in the background. Let's wait until the scan starts. Yes. So this scanner, because of the new lights you can see here, which are very powerful, we are really able to scan in a very, very high speed. So you can see here, one of the scans is only 20 seconds for the full table. So you can scan 60 centimeter in 20 seconds by 4, of course. So it needs, with preparing the modes, it needs around 2 minutes to have the scans done. So which is very, very fast. What is very fast? So. Okay, let's wait until the second scan also finished. Now switching the lights to the right side, and before the light was directed from the upper left position to here, and now the light comes from the right position. So we don't need to wait to go up. Now you need to, the shadows will now appear on the other direction, you will see. Okay. Now the first two scans are ready, and the software will tell me now I need to switch this light angle plates we have here in the lamps. So I just need to take it out and switch it from the left to the right lamp and from the right to the left lamp. So now I have the light directions in the opposite way, and I'm doing the third and the fourth scan. So starting now already.
Martin, you've had a question already from Vladimir. What light source is used on the scanner, LED or bulb?
These are very high power LED lights, which are temperature controlled to have a stable lighting over the whole scan process. And yeah, these are completely new, developed to have very fast scans, to be able to scan in this speed, so, which is really very fast.
The question from me is, what you're doing with the CS scanner, the model you're using, is it the same process for the larger models that you offer?
These lights now are a little bit more powerful, but because the larger models have more lighting possibilities, so I have the possibility to get a left texture mode with different settings, so I can move the light more to the left. I can, yeah. So maybe I will open the presentation again and show you a little bit from this. So if you see this scanner here, I hope you can see the mouse. It's able to move the lights also to the left and to the right and up and down. So this is not possible with the small scanner. So it was possible to develop this light a little bit or much brighter than the other ones. So this is why we are able to scan this fast. So,
Okay.
now the scans are.
Vladimir, what's the lifetime of your lights?
It's around 40,000 hours working hours is the estimated lifetime. So that's normally it's not necessary to change it in the scanner lifetime. Let's say like this. So what now happened is the 4 scans was ready, and automatically the factory software is starting. So as the scans are ready, I will make this bigger. And I see already the first preview of my result, which is a grayscale file or grayscale view, where the white points are the highest and the black points are the lowest from this thing. So what I need to do then is I can just simply start the calculation, because as you can see, it's not very precise now. So, but during the calculation is running, it will get more and more details. So the first thing was only a preview. And the software is calculating here, what you can see here with the red bar, the software is fully usable. Yeah? So I can already open the shaded view, which is a 3D view, using the depth information and the color information. And here I'm able to change my lighting. You can see the light around the original. You can see the shadow is moving when I'm moving at the upper left position, the yellow border a little bit around. What I can change the intensity here, and then what I set up here, I'm able to export again as a normal scan file. So I'm able to reproduce later using the depth information any lighting I want to do. So I can add more lights here. I can remove them and adjust them manually. So I have a lot of possibilities to get virtually generated new light positions or light effects. But what we need today for the demonstration is we need the grayscale file until, it's close to be ready already, and then we will pass this to Rachel, and Rachel will work on it in the AVA software and do the repeating magic, for example. So, and yeah, that's already done. So I think we did, I don't know how long it was, 5 to 10 minutes, and we have already a very high resolution 3D depth information file, including the color. So we see here the diffuse color image is a calculated color image without any shadows or gloss or reflection effects, which is necessary to use as the color, which is Stefan Cruse from Roland later using as the color layer on top of the height after he printed it. So for this is diffuse color is also calculated using our software. So I think that's already everything. So I will save the project, and then Rachel will use this project to go on.
Thank you, Martin. That was terrific. Thank you. So as Martin said, the data is going to be shared with Rachel. Whilst Rachel's just switching over the screen sharing to her screen, for those of you who are unaware, last year we developed a native interface for the Cruse scanner. So our software can now import the 3 key elements from the scanner, which is obviously RGB scan, but also the height map and the glossy, the reflective areas of the scan, if it's been scanned with such areas. We've been adding features regularly since last year to make the tool of the application a really nice interface, next step of the process in terms of developing, editing, repeating all the data. Are you ready, Rachel? I'll unmute you.
Thanks. Hi everyone. Thank you, Duncan, and thank you, Martin, for that presentation. So as you can see, I've now got the file here from Martin, and we can import all of those scans, all of that data that Martin's just scanned in. So we get the height map, which I've inverted. You'll notice that looks a bit different from Martin's. I've inverted it because AVA uses the dark side for the height and the light tones as the low marks. So just to explain why that looks a little bit different from Martin's. And then we have the highlight and the diffuse image. So all of this data is imported on Open. It opens and merges the document in one go. So the first thing I want to do really is I want to put this document into repeat. So I'm just going to select my crop box. So let me just close that one. Here we go. So I'm just going to select my crop box. Okay, this is the document, sorry. And I'm going to mark out an area for my single repeat. Like so. And I'm going to take this area and put it into a new document. So crop to new document. And then I'm just going to lay these out side by side. So now we have the original document on my left-hand side and the cropped version on the right-hand side. I'm going to put this into a repeat, so 2 by 2. Sorry, that's the wrong document. Sorry about that. Let me just put that back into 1 by 1. So the new document goes into a 2 by 2 repeat, and I'm going to frame the first repeat so that we can clearly identify what my tile unit is. So this blue line here on the right, that is the crop box from the original, okay? So I'm going to use, oh, didn't mean to minimize that. Sorry. There we go. So I'm going to use my carbon copy tool to edit the repeat join of this new document. Now, if I just show you the settings quickly for this tool, we have relative fixed and same. They're the same settings that the Adobe Suite has, for example. but we have this crop box mode. And that means that instead of using a specific cursor point as a source to copy from, we can use a crop box. So I'm going to activate all of my layers here.
Rachel, can I just interject? Just a comment from Nerton to say she can't see the screen. If anyone else can't see it, please let us know. But just to reassure, we are recording the webinar, so we'll be happy to share that with people who've had problems seeing the three sections of the webinar. Okay, thanks, Rachel.
Duncan, can you see the screen?
I can.
Should I continue?
Yeah, I think so. Stefan, can you see it?
Yes, yes, I can also see it.
Okay, so apologies, Nerton. But please let us know if you've had problems seeing this ambitious webinar today, and we'll send you a copy of the movie.
Okay, so I'll just continue, and hopefully those who can't see it will hopefully get a view shortly. So yeah, I'm using a carbon copy tool with a source point set to crop box. So as I set my cursor to copy from this document, it's going to locate where my cursor is in the new document because it's using that crop box as a source. And that means that I can very quickly just come in here and painting from the original document, I can put this design, this document into repeat fairly quickly. I can resize my cursor as I go so that I can be a little bit more specific in these areas. Okay. And just fix this. So obviously, I would take a little longer to do this in real life, but I just want to show that the power of this tool for copying from the original document into a new document and how rapidly this file can be put into a nice looking repeat.
For those of you who are familiar using Photoshop, this is a massive time saver. The tool Rachel is using for endless repeating is very rapid. It's very intuitive. It's not complicated to teach or learn, but it does generally save you a lot of time if you are working with a repeating pattern.
Okay, so I'm quite happy with that. So I'm just going to drop it back into I'm going to put it into multiple repeats now so that we can just check that for any repeat issues like so. So happy with that. So I'm going to close down my original document because I'm finished with that. And now that this document's in repeat, I want to see what it's looking like in 3D. So I'm going to open this window here. Oops. Oops. And I'm going to have a look. Now, as you can see, this window visualizes this document in repeat, but also in its structure. So I can, for example, change the viewing angle. I can change the lighting. And I can change the scale. I can also view the structure on its own, which really helps with the ability to locate issues that may arise when we put this document into production. And the power of this window is the ability to make those corrections in real time. So you can work in the 2D view. So essentially what's happening here is it's using this grayscale layer that you'll see on your left. It's using this grayscale layer to create this height map. So if there's any problems with that height map, I can come in here and I can edit it in real time. But just before I do that, I also want to draw your attention to this section down here, which is where we can load in production profiles. So we can change the property of the product. We can choose whether it's glossy or not. We can choose the material roughness here, and we can apply curves from production. So if you have an engraving curve, that can be put in here too, and also the height in microns that this is going to be produced at. Now I've pre-saved some profiles, so I pretend that my company uses two processes for embossing. It uses a chemical process and it uses a laser process. And at the click of a button, I can restore these processes. So there's my chemical emboss, and here's my laser emboss. And of course, I can be viewing that with the image on top of it as well, and change the lighting, for example. So,
can I add some detail, Rachel, please? Obviously, if you're an engraver, this will be quite self-explanatory to you. We have worked with a number of engravers with this tool, and it has proven to flag errors in the engraving prior to engraving. So when you're viewing 3D information, you do tend to see errors or unwanted areas in the file, such as banding in a texture or any nasty reflective areas, which will obviously come out if you were to engrave. However, if you're a designer and you're developing a product, you can still use this tool, this application, to see areas which are satisfactory to yourselves. But as Rachel, we're stepping into the area now where Rachel's actually can edit the data. She can mix different structures together. She can redesign the structure to produce a product to her liking. And just to pick up on the point where Rachel was going through the different embossing profiles, if you have a very good relationship with your engraver, I guess it's possible that you could obtain some profile information from your supplier so that you are actually looking at even more realistic previews at this stage, rather than, I don't want you to think that this is a tool for the engraver. It isn't just for the engraver, it's for everyone involved in the 3D process. Thank you, Rachel.
No problem. Yes, so I'm looking at this structure, and I'm looking for basically any problems that will show its head, if you like, that will appear when I put this, or before I put this into production. So I'm going to work in the 2D window, and you can see I've got my height map visible here. And as I move my cursor in the 2D view, I've also got a cursor in the 3D view. So this helps me to identify areas that I'm not very happy with and that I would want to correct before sending this to production. I'm going to use this tool here on my left. It's called the Fault Finder, and this is downloadable through the AVA software. As I click on that, it's going to add a red layer here for me to start drawing on the file to identify the areas that I need to fix. So I'm just going to, I'm keeping my eye actually on the cursor that's in the 3D view, but my active cursor, if you like, is in the 2D view. And as I see an area that I want to fix, I simply click, and it will put, if I zoom in, it'll put a little red circle in that area. So I know later on where I need to go back and focus on some editing and change those pixels. So I'm just going to mark out a few areas here. And then what I can do is I can really zoom in to those areas and start making some changes. So back into the 2D view, I'm just going to select this tool here, and that enables me to zoom right into a problematic area. So that I'll just re-zoom the structure window, and I'll zoom in to the 2D view as well. And it's this area that I want to kind of fix. Now, if I just show you, I'm going to make a selection. and I'm going to drag that over to the kind of chip, if you like, that I want to fix. Now I haven't copied and pasted, and you'll notice that in the 3D view, this area that has now been removed is completely flat. And the area where I've moved it to, the pixels have changed there. So I'm getting a real-time preview as to the editing of this height map. And I also have the light, the gloss layer, if you like, active too. So any changes that I make, the two layers are in sync. So now, just to make some more subtle changes, I'll just change the view of the 3D view, zoom right in here, and I'm going to make a selection. So I think I'll copy this area here, and I'm going to copy that and copy and paste it and put it over the area that I'm trying to resolve the problem with. So you can see now on the right hand side that that chip has changed its texture. I can also use tools like carbon copy and dodge and burn and gamma. So if I just carbon copy an area, for example, I want to perhaps exaggerate the edge here. So I'm going to copy from here, and I'm going to zoom in, oops, change my cursor size and just paint along that edge there, just to give it a little bit more exaggeration. Okay. I can also, for example, gamma this window. So I'll just change the curves, if you like, just to get a little bit more movement going on in these areas. So when I do that, you can see this is more contrasted. And then I can go in, for example, and I can start to use the dodge and burn tool to dodge the highlight. So I'm going to lighten the highlighted areas. And as I paint, you'll see the changes appear. They're much more subtle, but they're the types of changes that are important when you're editing these structures. Okay. So then, when I'm happy with all of my editing, go back to viewing this in repeat with the design on. So I just want to spend a few more minutes just developing this design further, because I'm now happy that it's in repeat, the height map's corrected, I've resolved any problems with once it's in repeat, there's no tracking happening, anything like that. So now what I want to do is I want to come into this design and separate it and add some colorways.
We're going to do this very quickly for everybody, this separation. Separation isn't for everybody, but if you are interested in this, we can show you a quick preview of how we do it and also the colorways. I think we've got a couple of minutes left, Rach, before we hand over to Stefan.
Yeah, so AVA has lots of separation tools. Sorry about this, just dropped my pen. Sorry about that, I've got it back. AVA has lots of separation tools, but I'm going to use an automated task here that will very quickly separate this design into 3 layers. Okay, so that's a great way of kickstarting any separation. And then I can simply just potentially just gamma that a little bit just to improve the separation.
And just for the audience benefit, we're only doing a separation for colouring. We're not doing a separation ready for engraving. It's simply for digital printing and proofing this process.
And then once it's separated, I can load in some colorways that I made earlier. So I'm just going to load in 6 colorways. Okay, let me just check that. There we go. So I can flick through these colorways now. So, and you'll notice as well up here that these colorways have color names. So I could share these between this design and potentially a coordinating design. But the beauty of this is if I go back into my structure simulation window, I'll restore those that repeat. You'll notice that my colorways transfer into the structure simulation window. So I can tab through those and just make sure that the product's going to look good. Okay. And then once I'm happy with that, I want to present it. So I'll just pop back to the design window and I'm going to open up a layout page. And I'm going to load in a pre-saved template. And this is the type of template that I use for all of my presentations. And you can see here that I have the design in repeat. I've got some colorways going on over here, some colorway concepts. And I've also got the product looking in 3D. And I'm ready to present that. So then once the design gets approved, I can then print that. And what we would do is we would process the print through, sorry about that, through a splitter technology. So it takes the height map and it splits it into layers. And then we send that over to the Roland printer, which Stefan is going to show you now.
Okay, so we're going to hand over to Stefan now for the Roland part, for the rapid prototyping. Thank you, Rachel. That's tremendous. Obviously, all the color that Rachel was using, we could apply a profile from the Roland printer so it is more color accurate. But thanks a lot. And over to you, Stefan.
Thank you. Thank you, Duncan. Thank you, Rachel, for showing us this amazing software tool. And to be honest, wherever you see a Roland printer for this application, you can see in most of the cases a Cruse scanner. And now with the AVA software, we really have the perfect connection bridge between the scanner and our printer. So that's really, really a nice thing. So my name is Stefan Höfs. I'm a business developer with Roland DG. And I will now show you how to bring all the digital data we have created so far back to reality. So we will now print the generated data from Rachel on a UV flatbed printer. That's our goal. Because at the end, what we all need to understand and experience a product is something we can hold in our hands and touch. But before I will go into detail, I will just tell you a little bit about Roland DG so that you just know who's talking to you. Roland DG is one of the leading manufacturers of large format printers. Actually, the company was founded during the first digital revolution in the year 1981. And our goal was always to create digital solutions to make the life of our customers easier. Today, we are one of the market leaders in the sign industry. So with more than 150,000 installations worldwide in more than 200 countries. And our net sales is about 340 million euros. Besides the products for the sign industry, where we are market leader, we also offer all kind of different applications for different industries. And the haptic proof is one of these applications. So now let's go into detail. I will explain you how the process works. I will in general explain you how digital printing inkjet printing is working. In our case, that's very easy. So what we have is actually a table moving from the back to the front. And we have a printhead scanning from the left to the right, from the left to the right, spitting at the same time ink on whatever object is lying on the table. That's the basic principle. For this, we are using a so-called UV ink. UV ink is a special ink that is curing when exposed to UV light. That's why we have placed the UV lamp next to the printhead on the left and on the right side. The advantage of an UV ink for our application is that with an UV ink you are able to print thick layers of ink. And this is needed to build up the tactile surface. So the colors that are available is a CMYK, like in the desktop inkjet printer you have probably at home. And we also have varnish, so-called gloss ink. We use this to build up the tactile structure in multiple layers. And we have a white ink. The white ink we normally print after build up the tactile surface, just to make the colors on top more brilliant. So colors are more brilliant when you print on white, as for example, if you print on black. So that's all about the technology. So maybe one other comment, the height of the layers we use to build up the tactile surface is depending on the print mode and a little bit the printer between 30 and 60 microns. Could be also less if, for example, you wanted to print very detailed leather structures. You can also print a 10 microns layer if you want. So before I show you the video that will make the process completely clear, let's go back a little bit to the pre-press process. So today we started with Martin showing the scan process. And for us, the most important outcome of the scan process are two files. First file is the black and white image presenting the height profile of the surface of the scanned object. For us, it's important that white is representing the height 0 and black is representing the maximum height. And the second file we need from the scanner is just the RGB, the high resolution RGB file that contains all the color information. So we started with the scanner process, then we went to AVA to manipulate the data. So what you are doing is you do all the manipulation, what is needed to build your mass production object. What for us as a printing solution is most important is, and Rachel already mentioned, is that AVA is also able to slice the height profile into different slices. In our case, we sliced it into 9 layers, which we use to build up the tactile structures with the varnish ink. And now I will show you the video. I'm using a lot of fast forward. The complete print process here normally needs 1 hour. So we are printing 9 layers of varnish, each layer with a height of 60 microns. Mine's at all, we have 540 microns height of the structures. And then we print the white and the color. So at the beginning, you see the normal speed of the printer. Starting with the first layer of varnish. I have to apologize a little bit the quality of the video, but actually I printed this yesterday and it was my first time I made a video and cut it. So I had to learn this yesterday. Next video will be better. So this is the normal print speed. 1 layer of gloss in an A4 format needs about 6 minutes. Later on, the white layer and the CMYK layer needs just 3 minutes each.
Stefan, you've had a question. What are the size options for your range of haptic printers?
Yeah, we have small UV flatbed printers with a width of 508 or 760 millimeters and a length of both 330 millimeters. But we have also bigger printers with a width of 1 meter and 16 and a length of up to, doesn't matter what you want, 3 meters. So here we have now the 5th layer, and you can already see the structure. And what you can also see is that the varnish is a little bit yellowish. And this is also the reason why we definitely need the white layer between the varnish and CMYK. So now we are finished with the structure. Now we print the white layer. And then at the end, most interesting, most amazing, the color information. And that's then the final product.
Martin, do you want to turn your video on so we can see the original and see what Stefan's holding up in Düsseldorf?
For sure. Wait a second.
That looks good, Stefan.
Should I stop? One moment.
Yeah.
It's a little bit too dark. Wait, I will.
Stefan, do you have yours available?
Yes.
Your counter, okay. Yeah, it looks good. Okay. And Stefan, do you have any more to add?
Yes, a little bit. So that was the printing process. So a few words where we were successful. To be honest, this is now an established workflow. And yeah, maybe a short story. When we did our first, because of the time, yeah, you think maybe it needs a long time to print these haptic proofs. But actually we did, our first customer requested a sample from us more than 5 years ago. And at that time we were supposed to print a wallpaper sample, 50 centimeters to 70 centimeters with a height of 1 millimeter. We did a good job, and also the customer was satisfied with it. But after a while, the customer asked us, how long have you printed on it? So 70 centimeters to 50 centimeters, 1 millimeter height. And we answered a little bit ashamed. We looked to the floor, 8 hours. The reaction of the customer was, what? Only 8 hours? That's amazing. We are normally waiting weeks for our 3D samples, and they cost a tremendous amount of money. That was actually the time when we recognized that we found and discovered a solution for all companies producing decorative haptic surfaces. And cost-effective and flexible and really realistic. So today this technology is really established. At the beginning, we had success in the wallpaper industry. The flooring industry was following. And now we have also some installations at car manufacturers. Some are using this technology for the design process, some for the proof process with the original data for mass production. All of this is possible. And maybe the last slide also to your question about sizes. We have some printers with which you can do this application in different sizes. Normally UV flatbed printers are built to be productive, but these printers are using fine art printers, so they are very precise and have a very high quality, because for our application, it is most impossible to come as near to the mass production product than possible. And that's it. If you have more questions, please come and go in contact with us. I think Duncan is sharing all the contact information. Thank you very much.
Yeah, I hope you can see that, everybody. Well, thank you very much. First of all, thank you to Cruse and Roland for joining this webinar. And thank you to the audience. Thank you so much for attending. Hopefully you can see our contact details. Anyone who's got problems reading the screen, it's crusescanner.com for Cruse, avacadcam.com for AVA, rolanddg.co.uk for Stefan, or rolanddg.com.
Sorry, Duncan, you need to share your screen.
Is it? Right, okay. Let me try again. Okay, is that better, Rachel?
Yes, thank you.
Okay. Thanks, Rachel. I've got two screens, so complicated for me. Those are our contact details. Thank you so much again for attending. I hope that was useful and gives you some ideas about certainly scanning, editing and rapid prototyping of 3D files. To repeat the point I made earlier, we were using probably a design which was a bit more tailored towards flooring and ceramics. But again, the technology is viable for wall coverings, potentially textile applications. We do have a number of carpet and rug companies who are interested in this rapid prototyping technology. Anyone who's interested in reducing the sampling process, I think it is comparable and viable. But I think we'll conclude now on time at 11 o'clock in London. I don't want to talk about time zones, but thank you very much, everybody. I look forward to hearing from you.
Thank you.
Okay.